Robbie, are you ready for your bedtime story?
Yes, Matthew.
Okay. This story is called The Pet Keeper. Once upon a time, there was a man named Mr. Washington, and he decided to open a pet store. He sold lots of different pets to the customers that came in. He sold some dogs,
Woof.
and also other cats.
Meow.
He sold a few other pets such as birds, fish, and hamsters. Mr. Washington used to sell each pet for $20, and he made around 10 customers a day. But then he decided that he was not making enough money, and he needed more money for his wife, Tricia, and his two sons, Billy and Robert. So he decided to decrease the price of each pet from $20, and he decreased it by $1. And then he found out that by decreasing the amount of money of $20 per pet, he got 2 more customers. This helped him in the end. The end.
Did the change of the money price help him in the end to make a little more money?
I'm not sure, Robbie. I'll have to check, and I have some free time now. I could do the math, and I could let you know in the morning. Is that a deal?
Okay.
Alright, good night. Hi. I am going to be doing a revenue profit problem. This is in regard to the question my little brother Robbie asked when I was reading him a bedtime story. So in his story, there was a guy who had a pet store. The guy's name was Mr. Washington. And practically, I took the story and put it into a word problem. So the word problem is Mr. Washington, who is the owner of the pet store, used to sell his pets for $20 a pet, and he got 10 customers a day to a store. He wasn't making enough money. So, to try to make more money, he decided to reduce the price of the pets by $1, and in the end, he ended up getting, not 10, but 2 more customers than the 10. So that's the word problem. My brother Robbie asked, so after making this change of reducing the price and by $1 and getting 2 more customers, in the end, did he end up getting more money or revenue with this change? And if so, meaning if he did end up making more money, how much more money? So he's a very intellectual little first grader. So that's his question. I was reading him a bedtime story, then he asked me, so with this change, did he make more money? I was like, let me do this for math. So, yeah. So I just want to discuss a few terms in this video before I just go ahead and talk and explain, because then some people might get confused. So revenue, which is the money Mr. Jefferson in this problem is making, equals, or is, to find revenue, you do price times quantity. So price is the money that the items you are selling, so in this case, the pets that Mr. Jefferson is selling, how much the items or the pets are being sold for, and quantity are your customers. So for example, in the last problem, the revenue, so Mr. Washington, before he changed his price, just to explain, he used to sell the pets for $20 and get 10 customers. So see, price is $20, and the quantity is the customers, 10 customers. So the revenue, you just multiply. So revenue, I'm just going to say R, because it's practically the same thing, equals 20 times 10, which is 200. So he would make $200. Because, and that makes sense, because if you think of it, if each pet, the number of items that you sell for, which is the price, $20 for each pet, and he had 10 customers, each customer would pay $20. So one customer would pay 20, the other would pay 40, and so on and so on, so you got to 10 customers, which would be 200. So that's your revenue. The price of what you sell an item and how many customers end up buying your item. How many customers times how much the price, which we just explained. So that's revenue. And then there's also this word profit. So what is the difference? So revenue we just explained. Profit is your revenue, so how much money you have, but then you need to subtract how much money you need to pay out of this $200 that you get for your business for other things for your store. So for example, maybe Mr. Washington had to pay $10 for pet food. I don't know, I'm just making this up. And maybe he also had to pay $20 for electricity. I don't know. I'm just making this up. This isn't realistic at all. So please do not believe this at all. And maybe he had to pay the cleaning lady that comes in every Tuesday to his store to clean up $5. And maybe he had to pay for cages for about $2 per pet. Well, you have to pay to get certain items for your store. You don't just get items. So this is how much money you get just from the customers and selling. But then your profit is how much you actually wind up with at the end of the day. He doesn't wind up, Mr. Washington, with the $200. What he ends up with is how much money at the end by subtracting from how much he is, first thing from the revenue, how much he is subtracting, after he takes out all the money of the different items that he has to pay for, how much he ends up actually getting at the end of the day in his wallet. So that's the difference between revenue and profit. Just to summarize one more time, revenue is how many customers times the price of each item, because that gives you how much you make. And then profit is revenue, and then from the revenue you're taking out how much money you have to pay for other things for your store or business, and how much money you actually wind up with at the end of the day. So we explained revenue, we explained profit. So now I want to put the word problem into, I'm sorry. I want to put the word problem into numbers, and use the following equation, which we just explained before, that revenue equals price times quantity. So I had the word problem here, the words, we're going to put it into numbers here. I think this is honestly the hard part, putting it from the words into the numbers. So I'm just going to use R from now on as revenue. So it's the same thing, equals the same thing. So if we have revenue, then we have to have a place for price and a place for quantity. So I'm going to read the problem again, and I'm going to underline all the places where there's a price. So Mr. Washington used to sell his pets for $20, that's a price, a pet, and get 10 customers a day. He wasn't making enough money, so he tried to make more money. So he decided to reduce the price of the pets by $1. So I'm going to underline reduce and by $1. And in the end, he got 2 more customers. So we had $20 and reduced by $1. So we're going to put both those prices, and so those are the prices, into the price part of the parentheses. So price is originally $20. So I'm going to first write this out. So an easier way to think of this is you do original plus or minus, depending on whether it's reduced or add, new times original plus or minus new. And this is normally for the price, so how much money, and this is like people or customers or what you get out of the money. So the original is he originally sold the pets for $20. And the new is he's reducing the price by $1. So reduce is minus, because you're taking away, reduce is subtraction, 1. The quantity is, so I'm going to read the problem again and now circle the quantity, which like we said before, and when we were explaining revenue, customers, or what the money is used for. So Mr. Washington used to sell his pets for $20 a pet and get 10 customers. 10 customers a day. Wasn't making enough money, so he tried to make more money. He decided to reduce the price of the pets by $1, and in the end he got 2 more customers. So following this original, so he originally had 10 customers, and it's not money anymore because it's customers quantity. And then he got 2 more. So more is plus. So we're using plus here, we're using subtract, and then we're using plus 2, because he had 2 more. So we're not done. Now, next to the 1, the negative 1, and the plus 2, we have to put in x. X is the number of increments you are making to the change. So just like this is the change, the subtracting $1 per pet. So this is like your x, like the per pet, and this is 2 more customers, like per day. So your x is like your what's it called? It's like the change. So this is the equation that we use. So our revenue equals 20, the original, minus the reducing, the $1 times the x, which is like the one which is like the increment of change, the per pet, and then you had 10 customers originally, plus the two new ones once you made the change in price, and this x is per day. The whiteboard. So again, this is a revenue maximum problem. So there are 2 ways, you just got the equation, there are 2 ways to solve the equation. So one way is using standard form. Standard form is y equals ax squared plus bx plus c. And the second way is intercept form, which is y equals a times x minus p times x minus q. This might seem a little bit confusing, but don't worry, we are going to explain it. So here we have the vertex of the 2 different types. In your vertex, which is always an x, comma y. Your x is the x that we just that we wrote in the last problem, the minus 1x, like how much you are making a change to the number, or plus the 2x, like how much increments you are changing it by. So that is how we're going to find the vertex, and now we're going to explain how to find the vertex with these 2 different forms. So the first way is standard form. So once again, we said standard form is y equals ax squared plus bx plus c. Your vertex is negative b over 2a. I'm going to now explain this. So we got our equation, which we saw before here. So in standard form, you are going to use FOIL. So first we're going to do 20 times 10 plus 2x, and then negative 1 times 10 plus 2x. So 20 times 10, so r equals 220 times 10, positive 20 plus positive 10 is 200. Positive 20 times positive 2x is plus 40x. So we did this, and now negative 1x times positive 10 is negative 10x, so we did this, and then negative 1x times positive 2x is negative 2x squared. So now we're going to combine this, so r equals 200 plus 40x times 10x is same as, or equals 230x minus 2x squared. And look, we got it, y, or r, equals ax squared, which is the negative 2x squared, ax squared, plus bx, plus the 30x, plus the c, plus 20, which has no x here, no x here, so we got this. So in this type of problem, this is your a, this is your b, and this is your c. So if our vertex is negative b over 2a, so vertex equals negative b, which is your 30, over 2 times a, which is negative 2, then you get negative 30 over negative 4. And negative 30 divided by negative 4 is a positive 7.5. So 7.5 is now your x, so your x value, as we were talking about before. So vertex, we said, is x comma y. 7.5 is your x. So if you put that back into the equation, r equals 20 minus 1x times 10 plus 2x, and you put this into your x values, r equals 20 minus 7.5, which is, remember, your price, times your quantity, Isn't that funny? Which is 10 plus 2 times 7.5. Trust me, I have done the math. So 20 minus 7.5 will get 12.5, which is your price. And then your quantity, which is 10 plus 2 times 7.5, you will get 25, which is your quantity. So now your new revenue, which is 12.5 times 25, turns out to be 12.5 times 25, which is $3.12.5. So now, with this new 7.5 amount, which we used as the X, we now put it in, and we get that our new price is, of 12.5, and getting 25 customers, you'll get $312.5. So now this is how much Mr. Jefferson, Mr. Washington, President, Mr. Washington will be receiving for his pet store, which answers Robbie's question that yes, he will be making more money. Okay, and so this is the second way that we are solving the problem, which is the vertex form. So vertex form, you use P plus Q over 2 divided by 2 to find your vertex. And remember, vertex form is just Y equals A times X minus P times X minus Q. And then you find the vertex, the P plus Q over 2. You might say, what is P plus Q? Well, let me explain. So this way is you set each of these to 0. So you do 12 minus 1x equals 0, and 10 plus 12x equals 0. Then you just do regular algebra, so you subtract the 20 on both sides. These cross out, you get negative 1x equals negative 20. You divide the 1, and x equals 20, because negative 20 divided by negative 1 is a positive 20, and then here you do the same thing, minus 10 on both sides. This crosses out. Positive 2x equals negative 10 divided by 2 on both sides to get x by itself. Get x isolated, and then negative 10 divided by 2, you get a negative 5. So this is one set, and this is one set. So this is, call it your P, this is, call it your Q. It really honestly does not matter. So now your P is, we're calling it 20, and your Q, we're calling it is negative 5. So you just name each one after setting it equal to 0, one side your P, and one side your Q. So now that we got the P and Q, we just plug it in. So P plus Q over 2. So we just plug it in. So P is is positive 20, I am sorry, plus Q, which is your negative 5 divided by 20. And then simplify this, so 20 plus negative 5 is 15 divided by 2. You just carry this, the divided by 2 over, and then 15 divided by 2 is just 7.5, which is your x, which is the same value as 7.5, which we found last time. So now erasing all of this, so we got the 7.5. So from the P plus Q over 2, we got 7.5. Plugging 7.5 back in for the x, 20 times 1 times 7.5 times 10 plus 2 times 7.5, you get 302.5, which is what we got last time from the standard form. And then your vertex, the middle, the P is the 20, the Q is the negative 5. And then you make a parabola like this, and your vertex, which is your middle point, is the 7.5, which is the x, and the 3.2.5, which is your y.
We're 1,000 miles from comfort. We have traveled land and sea.